In question number 16, a nucleus X initially at rest undergoes alpha decay according to the equation X Z 232 given the product Y 90A plus alpha. We want to find what fraction of total energy released in decay will be the kinetic energy of the alpha particle. Here we will use conservation of linear momentum, as initially this product was at rest. The initial linear momentum of the system will be 0. So 0 is equals to momentum of Y particle plus momentum of alpha particle. So magnitude of momentum of Y particle is equals to alpha particle. Momentum can be written as under root 2 m into kinetic energy. Let's say ky is the kinetic energy of Y is equals to under root 2m alpha k alpha. From this we can write my ky is equals to m alpha k alpha. So k alpha by ky is equals to my by m alpha. Here mass of Y will be 228 because due to alpha radiation the mass will reduce by 4. So is equals to 228 divided by mass of alpha is 4 AMU. Now total energy is equals to K alpha by Ky. We want to find K alpha by K total. So for this ratio we can write K alpha divided by K Alpha plus Ky is equals to 228 divided by 228 plus 4. That will give us the answer 228 divided by 232. So option 2 is correct option. In question number 17, the decay constant we want to find for the radioactive element which disintegrates to 10 grams from 20 grams in 10 minutes. Here the mass is halved from 20 to 10 gram in 10 minutes. So the half-life of this material is 10 minutes. Now decay constant is 0.693 divided by T half, that is 0.693 divided by 10 per minute, that will be 0.0693 minute inverse. This is the value of lambda. So option 4 is correct option. In question number 18, the half-life period of radium is 1600 years. 2 gram of radium undergoes decay and gets reduced to 0.125 grams in how much time? Here N is equals to N naught 1 by 2 power n. This is the formula we will use. In this case small n is the number of half-lives passed. Here the value of n is 0.125 gram and initially the amount was 2 gram is equals to 1 by 2 power n. So 1 by 2 power n is equals to 1 by 16. So n is 4. So there are 4 half-lives spent. So total time will be 1600 into 4, that is 6400 years. So option 4 is correct option. In question number 19, a radioactive sample contains 600 radioactive atoms. That means N0 is 600. The half-life period is 30 minutes. We want to find the number of radioactive atoms remaining if the decay occurs for 90 minutes. Here 90 minutes, that means 3 half lives are spent. We will again use the formula N is equals to N0 into 1 by 2 power N. 1 by 2 power N is 3. That will be 600 divided by 8. So N is equals to 75. So option 4 is correct option. In question number 20, after certain lapse of time, the fraction of radioactive polonium undecayed is found to be 12.5%. So N by N0 is equals to 12.5 divided by 100. We want to find the duration for this time lapse given the half-life is 138 days. N by N0 is equals to 1 by 2 power N. Here N is the number of half-lives. N by N0 is 12.5 divided by 100. That is equal to 1 by 2 power N. Simplify this, we will get N is equals to 3. So total number of days will be 138 into 3. That will be 414 days. So option 1 is correct option. In question number 21, two radioactive substances X and Y initially contain same number of atoms. That means N0 for both of them is same. We want to find their half-lives. The ratio of half-lives are 1:2. We want to find the ratio of rate of disintegration after 2 hours. The rate of disintegration dN by dt is equals to minus lambda n. So we can write dN by dt is directly proportional to lambda and it is inversely proportional to T half. So dN by dt for X divided by dN by dt for Y is equals to half-life of Y divided by half-life of X, that is given 2:1. So option 2 is correct option. In question number 22, it is given that a certain substance decays to 1/32 of its initial activity in 25 days. Here N is equals to N0 1 by 2 power N. N is the amount of substance after 25 days, that is N0 by 32 is equals to N0 into 1 by 2 power N. From this we will get N is equals to 5. That means 25 days is equals to 5 half lives. So 1 half life is equals to 5 days. So option 3 is correct option. In question number 23, we want to find the number of uranium-235 nuclei required to undergo fission to give 9 into 10 power 13 joule of energy. Here for one atom the energy released is 200 mega electron volt. So number of nuclei that should undergo the fission to get 9 into 10 power 13 joule energy is divided by 200 into 10 power 6, converting this mega electron volt into joule, into 1.6 into 10 power minus 19. Simplify this, we will get approximate answer 2.8 into 10 power 24. So option 1 is correct option. In question number 24, we want to find the energy released by the fission of 1 gram of uranium-235. Here, number of atoms in 1 gram of uranium will be N is equals to 6.023 into 10 power 23 divided by 235. That will give us the answer 2.563 into 10 power 21 atoms. Per atom energy liberated is 200 mega electron volt. So here total energy will be 2.563 into 10 power 21 number of atoms into 200 10 power 6 1.6 into 10 power minus 19 joule. So total energy will be 8.202 into 10 power 10 joule. So option 3 is correct option. In question number 25, we want to find the amount of energy released in the fusion of 2 hydrogen atom to form 1 helium nucleus. Binding energies for both are given. Here the reaction will be 2H4 is formed from 1H2 plus 1H2. The number of nucleons is number of protons plus number of neutron. So for 2He4 the energy will be 4 into 7. Given energy per nucleon is 7 mega electron volt, that is 28 mega electron volt. And for 1H2 energy will be number of nucleons are 2 and energy per nucleon is 1.1, that is 2.2 mega electron volt. The energy released will be 28 minus, here there are 2 atoms, so that will be 4.4 is equals to 23.6 mega electron volt. So option 3 is correct option. In question number 26, we want to find the ratio of amounts of energy released as the result of fusion of 1 kg hydrogen, that is E1, and fission of 1 kg of uranium 92-236, that is E2. First we will find the individual energies. In the fusion, energy released E2 is given by 200 into 1000, because per kg that means 1000 gram, divided by 236 into Avogadro number 6.023 into 10 power 23. Simplify this, we'll get 5.1 into 10 power 26 mega electron volt energy. Convert this into joule. 5.1 into 10 power 26 into 10 power 6 into 1.6 into 10 power minus 19. That will give us the answer 8.16 into 10 power 13 joule. And energy released in fusion of hydrogen atom is 6.4 into 10 power 14 joule. Taking the ratio of E1 and E2, E1 by E2, we will approximately get the answer 7.28. So option 4 is correct option. In question number 27, we want to find the minimum amount of energy released in annihilation of electron and positron. Both electron and positron contain 0.51 mega electron volt energy. So total energy will be 2 times of 0.51, that will be 1.02 mega electron volt. So option 1 is correct option. In question number 28, a nucleus X splits into two nuclei having the mass number in the ratio A1 by A2 is equals to 2:1. We want to find the ratio of their radii, that is R1 by R2. The radii is directly proportional to mass number power 1 by 3. So R1 by R2 is equals to A1 by A2 whole power 1 by 3. That will give us the answer 2 power 1 by 3 is to 1. So option 3 is correct option. In question number 29, a matchbox of dimension 5 cm, 5 cm and 1 cm is filled with nuclear matter. We want to find the order of its weight. Here mass can be given as density into volume. Density of any nucleus is of power 10 power 17 kg per meter cube into 10 power minus 3 gram per centimeter cube, and here the volume of the matchbox will be 25 centimeter cube. Simplify this, we will get 2.5 into 10 power 15 centimeter cube. So the order is 10 power 15. So option 4 is correct option. In question number 30, it is given that speed of light were 2/3 of its present value, then the energy released in given atomic explosion will be decreased by what fraction? Let's say in present situation energy released is delta m c square. In that case energy released E2 will be delta m. C is 2/3 of its present value, 2/3 c square. Taking the ratio E2 by E1 is equals to 2/3 whole square. That will give us the answer 4/9. So E2 is equals to 4/9 E1. So energy released is decreased by fraction 4/9. So option 2 is correct option.